Right. Sorry, continue.
Okay. So you have carbon in all, organisms basically. So trees have a similar behavior because they can die. You see, when they die, they start to emit carbon in form of CO2, basically, to the atmosphere. So that's exactly what we want to know, how it's happening, because trees can die and can remain in the forest for 10 years, 1 year, half a year. We don't really know. We just assume that once they are die, we rest that number of CO2 particles. You see, because we are estimating. So we automatically say, we lose that. But it lasts still in the forest for a while.
But it's degraded
by different processes. Basically, for instance, fungi is very important. That's very important. And then insects, very important. But fungi, I could say. So what happens is depending on the species, there are species that have a composition, chemical composition, that is not, it doesn't allow fungus to attack easily. So they last more, basically. So you have some CO2 that remains for a while. So we are trying to understand that. But what we know is, the amount of carbon that we have in the trees over the ground, so the above ground biomass, as we call. That's what we are trying to understand more. But we don't really know what's happening in the soil, because the soil also, you have roots, you have other processes going on in the soil. That's even more difficult. So we know a little about what happened, in the aerial part, but we don't know what happened. And if you have what we call the upland forest, which is not, say, inundated forests or swamps, that's what we are studying. But then in swamps, you have the carbon in the soils are very important, because they tend to keep carbon and accumulate carbon in the soil, in the bottom of the swamp. And we don't really know how much, etc. So that's a particular question.
And how do you measure the carbon with, you have a carbon flux captors?
Yeah, we don't, it's very easy, because what we have is an estimation of the carbon. We are not really measuring the carbon fluxes with equipment that tell you what's happening. There are some towers that do that kind of work, that tell you how are the fluxes in this particular time and this particular area. That's more or less costly. We try to have that in Yasuní. And developed countries, you have many of those that are connected with processes and things, and even with agricultural fields. In Yasuní, we don't have that, and many other forests, you don't have that. But you have a good proxy of that, because you measure the amount of wood that you have. Yeah, so you basically, of timber. Okay. So basically, what you have is you use equations that consider the volume, of the timber, consider the density of the timber, and consider other aspects like the climate, for instance, and certain specific aspects of the type of forest, for instance. So these three things modulate these equations. And
it can be very interesting. So it's easier that okay, sorry.
So what is known now, because of previous studies, is usually you have that half of the amount of biomass. Say, if you take a tree and you weight a tree, which is difficult, but you weigh a tree, half of that weight is carbon.
For each tree?
Yes.
There is, because I've read that in a paper that there was a study some years ago about rainfall, maybe, or something.
Rainfall can be, yes. They work a lot with that.
And it was saying, from my memory, correct me if I'm wrong, that only 1% of the trees in the Amazonian forest were taking 50% of the carbon. Maybe I have it.
Maybe, but what they are probably arguing is that they are studying big trees, more than 10 centimeters. We are studying more than 1 centimeter, which makes a difference. So if you look more than 10 centimeters and then you look more than 30 centimeters and more than 1 meter, obviously that...
The bigger tree takes the bigger carbon.
Exactly. Yeah. So more or less, for you to have an idea, if we study more than 1 centimeter and then study more than 10 centimeters, in this range between 1 and 10, there's around 12% of the carbon and biomass. So in terms of the amount of carbon, large trees are more important. Yes.
You would say that every tree has the same average intake of carbon?
No.
Every species, no?
No, I wouldn't say so. I mean, every species, if you have a tree of the same species, same size, in average, yes.
Yeah.
Yes.
So
There is variation always in nature, always. But that's we assume that, yes. Yes. But it's specific to the species, so this kind of estimation, you have to take into account the species, in other words, because the good density are related with the species, specifics of the species. Good density, because you have light goods and hard goods. So an range of that.
And the harder the density of wood is, the bigger it takes carbon, or is it the opposite?
It's a good question. But if you have a tree of the same size, of light wood and hard wood, obviously the hard wood has much more carbon.
Of what?
If you compare two trees,
hardwood and
same size, hardwood and light wood. So the hardwood will have much more carbon because it has more condensated, carbon in the tissues, basically.
Okay. And to finish, there is this very debated issue about is the Amazonian forest a sink or a source of carbon? What would be your development about this?
Well, the kind of study that we have is allows us to deal with this question, but in a particular way. Because as I said, we are studying all trees with more than 1 centimeter, but in a big area, only one area. People from